Hello everyone, myself Rupam Das, Assistant Professor of Asansol Engineering College in Electronics and Communication Engineering Department. This is my first lecture. Name of the subject is Signals and System. Subject code PECIT 601C. Learning outcomes are at the end of the session, student will be able to understand what is signal and various types of signal. Contents are signal definition, continuous and discrete time signal, continuous valued and discrete valued signal, periodic and non-periodic signal, deterministic and random signal, even and odd signal. These are the reference book. First book is Signals and System by Anand Kumar. Second book Signals and System by Turun Kumar Rawat. Third book Signals and System by Ramesh Babu, and the fourth book is Signals and System by A. Nagorkani. First of all, the definition of the signal. In communication system, the word signal is a very commonly used. Therefore, we must know its exact meaning. Mathematically, signal is described as a function of one or more independent variables. Basically, it is a physical quantity. It varies with some dependent or independent variables. So the term signal is defined as a physical quantity which contains some information and which is function of one or more independent variables. The signals can be one dimensional or multi-dimensional. One dimensional signal, first, when the function depends on single variable, the signal is said to be one dimensional. Example of one dimensional signal is speech signal whose amplitude varies with time. Multidimensional signal, when the function depends on two or more variables, the signal is said to be multidimensional. The examples of multidimensional signal is an image because it is a two-dimensional signal with horizontal and vertical coordinates. Next is system. A system is defined as the entity that operates on one or more signals to accomplish a function to produce new signals. The figure demonstrates its interaction between signals and system. The types of inputs and output signal depends on the type of system being used. There are various types of system: communication system, control system, remote sensing system, biomedical signal processing. Lots of types of signal and systems are there. Next is classification of the signals. Signals are broadly classified into this category. Categories are continuous time and discrete time signal, continuous valued, discrete valued signal, periodic or non-periodic signal, deterministic or random signal, even or odd signal, energy signal or power signal. Next is continuous and discrete time signal. Continuous time signal is a signal of continuous amplitude and time is known as continuous time signal or an analog signal. The signal will have some value at every instant of time, and here xt, x represents the shape of the signal and t shows the variable is time, and this is the graphical representation of continuous time signal. Next is discrete time signal. If the signal is represented only at discrete instant of time, then it is known as discrete time signal. The discrete time signal have value only at certain instant of time. If we take the blood pressure reading of a patient and after every 1 hour and plot the graph, then the resultant signal will be discrete time signal, and this is the graphical representation of discrete time signal. The discrete time signal can also be visualized as a sequence of samples taken at uniform intervals, and it is denoted by xn, where x represents the shape of the signal and n shows the variable is time. Next is continuous valued and discrete valued signal. So in case of continuous valued signal, if the variation of the amplitude of the signal is continuous, then it is known as continuous valued signal. Such signal may be continuous or discrete in nature. Such signals is shown in the figure. So this is a figure for continuous valued signal. Next is discrete valued signal. If the variation of the amplitude of the signal is not continuous, but the signal has certain discrete amplitude levels, then such signal is called discrete valued signal, and such signals may be again continuous or discrete in nature, and as shown in the figure. Next is coming periodic and non-periodic signal. So in case of periodic continuous time signal, a continuous time signal which repeats itself after a fixed time period is called periodic signal. The periodicity of a continuous time signal can be defined mathematically as follows: कि xt is equal to x of t plus capital T0, condition of periodicity, where capital T0 is called the period of signal xt. In other words, the signal xt repeats itself after a period of T0. And this is the graphical representation of a periodic continuous time signal. Next is non-periodic continuous time signal. A continuous time signal which does not repeat itself after a fixed time period or does not repeat at all is called as non-periodic or aperiodic signal. The non-periodic signal do not satisfy the condition of periodicity as stated by the equation. So non-periodic signal is defined by the equation xt is not equal to x of t plus t0, and this is the one of the graphical representation of non-periodic signal. Here this exponential signal is non-periodic, but it is deterministic because we can mathematically express it as xt equal to e to the power minus alpha t. Next is periodic discrete time signal. For a discrete time signal, the condition of periodicity is xn equal to x of n plus capital N. Here the number n, capital N, is the period of signal. The smallest value of capital N for which the condition of periodicity exists is called as a fundamental period. And this is the graphical representation of periodic deterministic time signal, discrete time signal. Non-periodic discrete time signal, a signal which does not repeat itself after a fixed time period or does not repeat at all, is called as non-periodic or aperiodic signal. Thus, mathematical expression for non-periodic signal is xn is not equal to x of n plus capital N, and this is the graphical representation. Periodicity condition for xn equal to x1n plus x2n. Here the input sequence xn is expressed as summation of two discrete time sequence. We can calculate the value of f1 and f2 corresponding to x1n and x2n. Let us assume x1n and x2n both are periodic discrete time sequence or discrete time signals. So according to the condition of periodicity, f1 is equal to k1 by capital N1 and f2 is equal to k2 by capital N2. The resultant signal xn is periodic if n1 divided by n2 is a ratio of two integer. The period of xn will be least common multiple of n1 and n2. Similarly, continuous time signal is denoted by xt is equal to x1t plus x2t. We can also calculate the value of t1 and t2 corresponding to x1t and x2t. Then the resultant xt is periodic if t1 divided by t2 is the ratio of two integer. The fundamental period of xt will be least common multiple of t1 and t2. Next, we are having one mathematical question. State whether the following signal xt is periodic or not, and giving the reason. If it is periodic, find the corresponding period. now one expression is given to you, that is xt is equal to 2 cos 100 pi t plus 5 sin 50 t. So from we just first write down the expression xt is equal to 2 cos 100 pi t plus 5 sin 50 t, and I'm dividing the total expression into two part. Xt is equal to x1t plus x2t. x1t is equal to 2 cos 100 pi t and x2t is equal to 5 sin 50t. The standard equation can be expressed as x1t, that is equal to a cos omega 1t, and omega 1 is equal to 100 pi, omega 1 that is equal to 2 pi f1, and that is equal to 2 pi by t1. 2 pi by t1 that is equal to 100 pi. Next, t1 that should be equal to 2 pi divided by 100 pi, that is equal to 1 divided by 50. Similarly, standard equation for x to t can be written as x to t that is equal to a sine omega 2t. Omega 2 is equal to 50. 2 pi f2 is equal to 2 pi by t2, that is equal to 50. So from here we can calculate t2 is equal to 2 pi by 50. Here xt is expressed as summation of two signal. We know that the resultant signal xt is the periodic if t1 by t2 is the ratio of two integer. From equation 6 and 7 we get t1 by t2 that is equal to 1 divided by 50 multiplied by 50 divided by 2 pi. 50 cancel out, so it is coming 1 divided by 2 pi. It is not the ratio of two integer, so we can say xt is non-periodic. Let us assume another example. Determine which of the following signal is periodic. If periodic, determine the fundamental period. 10 sine 12 pi t plus 4 sine 18 pi t. So given signal is xt is equal to 10 sine 12 pi t plus 4 sine 18 pi t. xt is now again written x1t plus x2t. x1t I have taken 10 sine 12 pi t and x2t has been taken 4 sine 18 pi t, and xt is equal to a sine omega t. Here omega 1 we can write 12 pi. So from here we can write down 2 pi f1 that is equal to 12 pi. From that we can write if f1 that is equal to 6 divided by 1, and from that we can again write down t1 that is equal to 1 divided by f1 that is equal to 1 divided by 6. Next, similarly we can also write omega 2 that is equal to 18 pi, and omega can be written 2 pi f2 that is equal to 18 pi. f2 is equal to 18 pi divided by 2 pi. Pi cancel out and it is coming 9. From here we can calculate t2 that is equal to 1 divided by f2 that is equal to 1 divided by 9. The resultant signal xt is periodic if t1 by t2 is the ratio of the two integer. From equation 5 and 6 we can write t1 divided by t2 that is equal to 9 by 6. So it is the ratio of the two integer, thus xt is periodic. Now the fundamental period of xt is least common multiple of t1 and t2. Thus fundamental period is 1 divided by 3 second. Next we are discussing about deterministic and random signal. Deterministic signal is a signal which can be described by a mathematical expression, lookup table or some well-defined rule. It is known as deterministic signal. The examples of deterministic signal are sine wave, cosine wave, square wave, etc. Figure shows a sine wave which is a deterministic signal because it can be represented mathematically as xt is equal to a sine 12 2 pi ft, where a is the peak amplitude and f is the frequency of the signal. Next is random signal. A signal which cannot be described by any mathematical expression is called as a random signal. Due to this, it is not possible to predict about the amplitude of such signal at a given instant of time. The examples of random signal is noise in the communication system. The deterministic and random signal are shown in the figure. Next is symmetric signal of a continuous time. A signal xt is said to be symmetrical or even if it satisfy the following condition. So the condition of symmetry is xt is equal to x of minus t, where xt is equal to value of the signal of positive t, and x minus t, the value of the signal for negative t. And this is a graphical representation of a symmetric signal. Next, antisymmetric signal. For continuous time, a signal xt is said to be antisymmetric or odd if it satisfies the following condition. So the condition of antisymmetricity is xt is equal to minus of x minus t. So as per this expression, this is the graphical representation where it shows the antisymmetrical signal. Next is even and odd discrete time signal. Discrete time symmetric signal. A discrete times real valued signal is said to be symmetric or even if they satisfy the following condition. So condition of the symmetry is xn is equal to x of minus n, and this is a graphical representation of discrete time symmetric signal. Next, odd discrete time signal. Similarly, the discrete time signal xn is said to be antisymmetric or odd if it satisfies the following condition. Condition of antisymmetric, that is equal to x of minus n, that is equal to minus of xn. Now if you see this particular figure where it satisfies the above condition, that is x of minus n, that is equal to minus of xn. So this is the graphical representation of odd or antisymmetric discrete time signal. Next, one question has been given, one function has been given xt, and you are asked to find it out its even and odd part. So the even part is given by x e of t, that is equal to half of xt plus x of minus t, and odd part of the signal is given by x o t, that is equal to half of xt minus x of minus t. Now if I'm going to represent this graphically, so first we have to draw the signal xt, then we have to folded version of x of minus t, then xt and x of minus t, or subtract x of minus t from xt and divide the addition or subtraction by 2, and from that we can obtain the even and odd part of the signal. Now as per that, this is the signal. So to draw the even part, first I have represented xt, then this is the x of minus t version, then we have to add these two signal, that is xt plus x of minus t, then the representation of even function is half of xt plus x of minus t. So this is the total representation. Similarly for odd part, xt is the signal, x of minus t has been written, or in case of odd part, minus of x minus t, so it can be represented like this. And if I'm going to obtain the odd function of the signal, so it can be written half of xt minus x of minus t. So this is the representation of even part, and this is the representation for odd part. Next, we are going to see another question. In this particular question, uh, consider one signal is been some of the signal is been given to you, and you are asked to find it out. Consider the signal and state which of these signals are even and odd. Now this is three figures have been written. In the first figure we can easily see keep in my previous, as per the previous equation has been concerned, this is the odd signal, and this is the representation of the signal for the even, and for the third it is neither even or nor the odd function. So from that we can represent that this is a neither even or nor odd type of signal. So this type of question it can be asked in your semester examination. Some figures are been shown to you or given to you, and you are asked to find it out whether the signal is even or whether the signal is going to be odd. So as per the equation we have found, depending on that you have to identify which portion of the signal is even and which portion of the signal is going to be odd. And these are the references for your future purpose. And up to this I am concluding my first lecture. Thank you.